Hello and welcome to this revision session on the particle model of matter, which is a topic in GCSE Physics Separate Science Paper 1. So in this revision session we're going to look at how you can answer examination questions on the particle model, which is found in GCSE Paper 1 as mentioned before. So if we've been successful and we've learned in today's lesson, we can answer GCSE Physics examination style questions, assess our understanding on GCSE Physics and understand what topics we need to improve upon for GCSE Physics. So how should you prepare for carrying out this revision session? Well, when completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than that on the right hand side, and in this left hand side section write down your working out answers to the questions in the revision session. So when you're doing this, make sure you write out your answers in full sentences and show your full working out, whilst in the right hand side write down any piece of information which you find useful or any hints and tips on answering questions from this revision session. At the end of this revision session, write up these notes into a revision sheet for you to use independently. So let's have a look at answering a few questions on the topic of the particle model of matter for GCSE Physics Paper 1. So this first question says the volume of a balloon is 14,000 centimeters cubed. The density of the helium in the balloon is 0.180 kilograms per meter cubed. Calculate the mass of the balloon. So pause the video now, then unpause the video when you want to go through your answer. Right, well the first thing you've got to do is use the equation for this, and that's density is equal to mass over volume. Now you'll note that when you've got the volume in this question, it's given in centimeters cubed when you want to be working in meters cubed, but they give you the conversion factor that 1 centimeter cubed is equal to 1 times 10 to the minus 6 meters cubed. So to convert, you would do 14,000 times by 1 times 10 to the minus 6, and we get our answer to be 0.014 meters cubed, is shown in the screen as follows. Then the next thing you do for any calculation question in GCSE Physics is you substitute the values directly into the equation. So we've got our density 0.180 equals mass over 0.014. You then rearrange it as shown here to make mass the subject. You then carry the calculation and you get 0.00252 kilograms. The next question says, this question is about solids. Describe two ways the arrangement of particles in a solid is different from the arrangement of particles in a liquid. You should answer in terms of the particle model. So pause the video now, then unpause the video when you want to go through your answer. Well, it's very important you can describe the differences between solids, liquids and gases using the particle model. So I will talk about firstly how the particles will move about or not move about, and secondly what arrangement they have. So you would say that in a solid compared to a liquid, there's a regular arrangement of or pattern of the particles, because in a liquid they're randomly arranged, but in a solid there's a regular arrangement. Secondly, we know that in a solid the density is higher, so the particles are packed in closer together. And then finally, in a solid, particles will stay in a fixed position, they will only vibrate, whilst in a liquid they're more free to move about. The next question says, the density of ice is 920 kilograms per meter cubed. Calculate the volume of 2.3 kilograms of ice. So pause the video now, then unpause the video when you want to go through your answer. Right, so once again we've got to use our equation density is equal to mass over volume. So once again we substitute our values directly in. Now this time all of our units are correct for this particular equation. So we've got kilograms for mass and kilograms per meter cubed for density. So you substitute the values directly in. So we say 920 is equal to 2.3 over the volume. The next step is to rearrange and then to make volume the subject. So as you can see on the screen, volume is equal to 2.3 over 920. You then for your final mark calculate your answer out, which is 0.0025. The next question says, describe a method to measure the mass and the volume of a liquid. So pause the video now, then unpause the video when you want to go through your answer. Well, it's very important that you can describe methods to work out the density of a regular shaped solid, a irregular shaped solid, and a liquid. Now, in this instance, because we're measuring the mass and the volume, that will actually work out the density as well. Because to work out any density, it's working on the mass of the substance, the volume, and doing mass over volume. This question doesn't go as far as that, but you've got to know how to work out the mass and volume of each. Now, how do you measure the mass? Well, the first thing for a liquid is you would measure the mass of an empty measuring cylinder or empty beaker using an electronic balance, it's always important to know that you measure mass with a balance. You would then pour the liquid into your measuring cylinder or your beaker. You would then measure the mass of the liquid and the vessel, and then you would subtract the mass of the vessel. Or what you could do is you could place the measuring cylinder or beaker on the balance and then zero it. Okay, then you would measure the volume with the measuring cylinder or beaker by reading on the side, and then make sure that to get this correct, you've got to have a level surface to have your vessel on and be looking an eye line, so there's no parallax error, and as well you should really be measuring the lowest point if it's dipping. So it's very important that you can state what equipment you would use and what measurements you take and how you would take it to get accurate values. The next question says, a student determined the density of a cube made of bronze. The student used a balance to measure the mass of the bronze cube. Figure 5 shows the balance before the cube was added. Firstly, what type of error is shown on the balance, and then how could the student get a correct value for the mass of the cube from the balance. So pause the video now, then unpause the video when you want to go through your answer. Right, it's important that you can identify key types of errors in scientific investigations. Now in this case, if the value should be reading 0, but it's not, it's reading 4.2, so it's what we call a zero error. Now a zero error is a type of systematic error, which means it's a constant error for every measurement that you would take. Now how could you get the correct value of the mass after you've got the zero error? Well, there's two ways you could possibly do it. You could either reset the balance to read 0, or you could subtract your zero error on the balance from all the readings that you take. So in this instance, subtract 4.2 from all values taken. The next question said, the student wanted to determine the density of a bronze coin. The student had several identical coins and the volume of each coin was very small. The student added water to a measuring cylinder, and figure 6 shows the student reading the volume of water in the measuring cylinder. Give 2 changes the student should make to increase the accuracy of the volume measurement. So pause the video now, then unpause the video when you want to go through your answer. Well, it's very clear that the student wants to work out the volume of the coin by using the displacement method. So by measuring the volume of the water beforehand, placing the object fully into the water, and then measuring the change in the water level as that is the volume of the substance placed in it. But how do you get an accurate volume measurement via this method? Well, we've already mentioned the 2 ways in which you've always got to state you would do this to get an accurate measurement. Firstly, you will place your vessel, your measuring cylinder, on the horizontal surface. It's always important that when you do the water displacement method, you state that you're placing your object on a flat surface. And secondly, you would view in line with the level of the water so you don't get a parallax error. You could also say, linking it into chemistry, reading from the bottom of the meniscus where the water level dips. The next question says, ice cream is made by cooling a mixture of liquid ingredients until they freeze. Which statement describes the motion of the particles in solid ice cream? Then how do the kinetic energy and the potential energy of particles change as a liquid is cooled and frozen? So pause the video now, then unpause the video when you want to go through your answer. Well, like we mentioned before, it's very important you can describe the arrangement of particles, how close particles are together, and how the particles move in solids, liquids and gases. Now you need to know it's just a fact that solids vibrate around fixed positions. Now as well as that, you need to know how the kinetic energy store of the internal energy and the potential energy store of the internal energy changes when you either change state or whether you change temperature. Now temperature links to kinetic energy and state change links to potential energy. Now because it's cooling down, the temperature is going down, which tells us that the kinetic energy is decreasing. Now it's also, the liquid then freezes, so it's changing state, so therefore the potential energy is going to change, so it's going to be decreasing. Now why is it decreasing and not increasing? Because when you freeze a substance, it tells you that you need to take energy out of it, it cools it down. Okay, so that's a very important idea. So both the kinetic and the potential energy decrease. The next question says the power of a kettle was 2.6 kilowatts. The kettle took 120 seconds to heat 0.80 kilograms of water from 18 degrees to 100 degrees Celsius. Calculate the specific heat capacity of water. Use this information and give your answer to 2 significant figures. So pause the video now, then unpause the video when you want to go through your answer. Right, with this type of question, it's very important you know what equation to use, and that is E is equal to mass times by specific heat capacity times by the change in temperature. That equation is given to you in your equation book for this particular exam. But the issue you've got here, firstly, is that you don't have energy, but you do have power and you do have time. So to work out energy, energy is equal to power times by time. But once again, we don't work in kilowatts, so we convert kilowatts into watts. So it's 2,600 because kilo means 1,000, multiplied by 120 seconds. This gives you an energy of 312,000 joules. So we then substitute the values into our equation and say 312,000 is equal to 0.80 the mass times by C, the specific heat capacity, times by 82, which is the change in temperature. It's gone from 18 to 100 degrees. We then rearrange and work out our answer and we get 4,756. But please don't remember the question asked you to work out the answer to two significant figures. So you start counting your significant figures with the first non-zero number in your value. So that's the first number, 4. So you'd count 4,756. So 4 and 7 are the two significant figures, but because the next value is a 5, it rounds up. So it's 4,800 joules per kilogram degrees Celsius. The next question says a different washing machine transfers 380,000 joules during a washing cycle. 65% of the energy transferred by the washing machine is used to heat the water from 11 degrees to 30 degrees. The specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. Calculate the mean mass of water heated by the washing machine. Give your answer to two significant figures. So pause the video now, then unpause the video when you want to go through your answer. Well, once again, what have you got to do? You've got to use our equation. Energy is equal to mass times by specific heat capacity times by the change in temperature. Now, you've got the change in temperature. It's 11 to 30, so that's going to be 19. We've got the heat capacity, 4,200. Now, we do have a value for energy, but we've got to read the question carefully because it says it has 380,000 joules, but only 65% of that is used to transfer the energy. It's used that to heat up the water. So we've actually got to work out what 65% of 380,000 joules is first. So to do that, you do 380,000 times by 0.65, so we get our answer to be 247,000 joules. We then substitute our values in and say 247,000 is equal to mass times by specific heat capacity times by the change in temperature, as shown here. You then will work it through and get 3.095, but the question once again asks for the answer to be given to two significant figures. So 3.095, we start counting out our first non-zero number, 3, so 3.0 is our two sig figs, but the next value is 9, so therefore it rounds up to be 3.1. The next question says an electric kettle is switched on. Figure 10 shows how the temperature of the water inside the kettle changed. The energy transfer to the water in 100 seconds was 155,000 joules. The specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. To determine the mass of the water in the kettle, use figure 10 and give your answer to two significant figures. So pause the video now, then unpause the video when you want to go through your answer. Right, so what can you determine from figure 10? Because it says you've got to use figure 10, so you should be doing this in your question. Well, you can work out the change in temperature, and it's after 100 seconds. So you see what it starts at, which if you look on the graph is going to be 22 degrees Celsius, and after 100 seconds is at 100 degrees Celsius, so therefore our change in temperature is 78 degrees Celsius. What we can then do is pop our numbers into our equation. E equals m times by C times by the change in temperature, so it's 155,000 equals mass times by 4,200 times by 78. Once again, just substitute the values into the equation first, then rearrange and make mass the subject, and then work out your answer. So you should get an answer of 0.4731 kilograms, but the question says give your answer to two significant figures. So you say 0 doesn't count because it's not the first non-zero number, so it's 0.47, and there's your two significant figures. The next value is a 3, so it doesn't round up, so it's 0.47 kilograms. The next question says the straight line of the line in figure 10 can be used to calculate the useful power output of the kettle. Explain why. So pause the video now, then unpause the video when you want to go through your answer. Well, it's very important in examinations that you can work out, given a graph, what the gradient represents. Now, the gradient of any graph is the y-axis divided by the x-axis. So what's our y-axis? Temperature. What's our x-axis? Time. So we can say our gradient is the change in temperature with time. Now, we know from our previous work that energy is equal to mass times by specific heat capacity times by the change in temperature. But we also know that time isn't here yet, so we need to put time into this equation. Well, energy is equal to power times by time. So therefore, power times by time is equal to mass times by specific heat capacity times by the change in temperature. So what we can do is we can now bring time onto the right hand side and say power, which is what we want from the question because that's what's asked us to work out, is mass times by specific heat capacity times by change in temperature over time. Now, change in temperature over time is the gradient, so the power is the gradient, the change in temperature over the change in time, times by mc. And there you can see in the answer in the question. The next question says, figure 14 shows a Bunsen burner heating some water in a beaker. Eventually the water changes into steam. Firstly, explain how the internal energy of the water changes as it's heated from 20 degrees to 25 degrees Celsius. So pause the video now, then unpause the video when you want to go through your answer. Well, what's happening here? Well, we're changing temperature. So that is the change in the internal energy of the particles, the internal energy store of the substance, focusing on the kinetic energy store of the internal energy. Because the kinetic energy of the internal energy links to change in temperature, and the potential energy of the internal energy links to a change in state. So what do we know? We are increasing the kinetic energy of the particles. So therefore, if the kinetic energy of the particles increases, the overall internal energy of the particle increases, which is what the question is asking you. So you can see it there. Now remember, you've got a kinetic energy store and a potential energy store in the internal energy store of the particles. The next question says, how is the particle model used to explain the difference in density between a liquid and a gas? So pause the video now, then unpause the video when you want to go through your answer. Well, again, it's very important to understand why you get different densities, and it's the idea that the potential in a gas have more potential energy than particles in a liquid, and that's an important idea to understand, because if you look at the particular options, particles in a gas have actually more kinetic energy than particles in a liquid. Particles in a liquid are further apart than particles in a gas. That's not true. The gas particles are more spread out, and the particles in a liquid are larger than particles in a gas. That's fundamentally incorrect as well. In the particle model, we assume the particles themselves are the same size in a solid, a liquid and a gas. It's only the space in between them that changes. But the particles in a gas will have more potential energy than particles in a liquid, because energy will have gone into changing a liquid into a gas, so therefore the particles are going to have more potential energy. The next question says, a student measured the mass of boiling water that was turned into steam in 5 minutes. Explain how the student could use this information to estimate the power output of the Bunsen burner in watts. So pause the video now, then unpause the video when you want to go through your answer. Well, it's important to note that in the question it tells us that we've got the mass and we've got the fact that the water is turning into steam, so it's changing state. So at this point we've got to use the specific latent heat in this particular equation to work out our value. So what can we do? We can say that E is equal to mass times by specific latent heat, which is an equation given to you in the back of the book. So we can say E equals ml. Now we're asked to work out the power output. Now we know power is equal to energy over time, so we can now link the two equations. So we can say that power is equal to energy over time, where energy is mass times by specific latent heat, L. So we can over the time. So power equals ml over t. Now the last thing we can say is that when we're working out time, it needs to be in seconds, because when we're working out power in watts, time needs to be in seconds. The next question said, a student measured the width of a solid metal cube using a digital micrometer. Figure 11 shows this micrometer. The resolution of the micrometer or micrometer is 0.01 millimeters. The student could have used a meter ruler to measure the width of the cube. Explain how using a meter ruler would have affected the accuracy of the student's measurement of width. So pause the video now, then unpause the video when you want to go through your answer. Right, so what links into accuracy here? Well, it's the idea of the resolution of our micrometer or micrometer compared to our ruler. Now, you should always link in resolution to accuracy in the following idea: that if you've got a lower resolution, which means you can measure to more decimal places, you've got if you've got I'll get this right, a higher resolution, sorry about that, a higher resolution, which means you can measure to more decimal places, that your value is more accurate. So what you can say here is as follows: because the meter ruler has a lower resolution and the micrometer has a higher resolution, it means that the micrometer is more accurate than the meter ruler, or the meter ruler is less accurate than the micrometer. Remember, the more decimal places you can measure to, the higher the resolution, the more accurate the value is. The next question says, the mass of the metal cube was measured using a top-hand balance. The balance had a zero error. Explain how a zero error may be corrected after readings have been taken from the balance. So pause the video now, then unpause the video when you want to go through your answer. Well, we've talked about zero errors before, but in this question it's paramount that you actually read the information given, because it's been said that the readings have already been taken. So we did mention previously about resetting the measuring device to correct a zero error, but you can't do that here because the values have already been taken. So there's only one method by which you can correct a reading after it's been taken by a balance, and that's to record the value of the zero error when there's no object on the balance. When it should be reading zero but it's not, then you subtract this value, okay, from your measurements that you've taken. The next question says, the width of the cube was 18.45 millimeters. The density of the cube was 8 times 10 to the 3 kilogram meters cubed. So calculate the mass of the cube. So pause the video now, then unpause the video when you want to go through your answer. Right, well, this question's worth 5 marks and for good reason, because there's a few things we've got to do before we can get our answer out. Now, we know density is equal to mass over volume, but before we can use that equation, we've got to work out what volume is. Now, the first thing you've got to remember is that in a cube, that the volume is equal to the length cubed, and we've got the length to be 18.45 millimeters. But the next thing you've got to remember before you start to work out the volume is we don't work in millimeters, we work in meters. So you do 18.45 times by 10 to the minus 3, because milli means times 10 to the minus 3, or divide by 1000, and then we cube that value. So V is therefore going to be equal to 0.01845 cubed. We know it's cubed because it's a cube. Then we can say the volume is therefore 6.28 times 10 to the minus 6 meters cubed. So therefore density is equal to mass over volume. So we can say 8 times 10 to the 3 is equal to mass over 6.28 times 10 to the minus 6. So therefore mass is equal to 8 times 10 to the 3 times by 6.28 times 10 to the minus 6. We work our answer out to be 0.0502 kilograms. The next question says, an ice cube has a temperature of minus 15 degrees Celsius. The total thermal energy needed to raise the temperature of this ice cube to 0 degrees and completely melt the ice cube is 5,848 joules. You've got both the specific heat capacity of ice and the specific latent heat diffusion of ice. Calculate the mass of the ice cube. So pause the video now, then unpause the video when you want to go through the answer. Right, this is a very challenging question because actually two types of energy store are changing when the ice cube has its temperature risen and then its state changed. Whilst both are linked to the internal energy, we know that the change in temperature is due to the kinetic energy store and the change of state is due to the potential energy store. Now we can work out the change of energy in the kinetic energy store by doing m times by c, the heat capacity, times by the change in temperature. Whilst we can work out the change in potential energy store by doing m times by L, the specific latent heat. So what we would say is the total energy is equal to the change in kinetic plus the change in potential. So we can now say that the overall value of E, which is 5,845, is equal to ml, which is m times by 334,000, plus MC triangle T. So it's equal to m times by 2,100 times by 15. So we work that out to be 5,848 is equal to 31,500 m plus 334,000 m. So what we can then do is add those two values of m together, and what we can say is 5,848 is equal to 365,500 m. We then rearrange it and make m the subject. We say m is equal to 5,848 148 over 365,500. So you get our answer out to be 0.016 kilograms. Please remember that if you've got the change in temperature, you're working out your change in the kinetic of the internal energy, and if you're changing your state, you're working out the change in potential for your internal energy. So read the question very carefully. So I hope you've been successful and you've learned in today's revision lesson. So if you have been successful, you should be able to answer GCSE Physics examination style questions, assess your understanding on the GCSE Physics topic, the particle model, then understand what topics in this area you need to improve upon for your GCSE Physics. So thank you very much for watching this revision session on the particle model, which is part of paper 1 in GCSE Separate Science Physics. Thank you very much and have a lovely day.